Hello everyone. Today we're going to talk about a very interesting and exciting project that has the potential to shape up the transportation industry, which is nothing but a fifth mode of transport, that is Hyperloop. Hyperloop was introduced in the year 2013 by Elon Musk, the CEO of Tesla and SpaceX, Tesla Motors and SpaceX, and he wrote a white paper on how a Hyperloop would work and how would it be sustainable, self-sufficient, and also how would it better the existing four modes of transport. So his paper was mostly written in terms of the first a tube or the first track being laid between Los Angeles and San Francisco. What we will try to do today is to actually understand his motivations and how the concept would work. So without wasting any time, let's go directly into the presentation. Okay, so what are the four modes of transport that we know already? Those are air, water, road, and rail. And now let's look into the fifth mode of transport, that is the Hyperloop. This is one of the earliest schematics of Hyperloop designed by Elon Musk. So what is a Hyperloop? Let's answer the basic fundamental question. Now, this idea is not. I would say it's not a very new idea in the sense that right from the 18th centuries, humans have been using pneumatic tubes, or there were proposed ideas about vacuum tubes and all. But this is very new in the sense that it doesn't use those ideas; it builds on those ideas. So let's look at how this works. Now, this mode of transport is a proposed mode of transport for both passenger and freight transportation, which instead of using a vacuum tube, it's actually near vacuum, that is low pressure containers or low pressure tubes, which propel the passenger pods or the freight transportation pods at almost the airline speeds, that is theoretically close to 500 miles per hour. Now let's look at so to summarize it, let's summarize a Hyperloop first. It's basically just a capsule full of people in a low pressure tube, as written here, which goes really fast. That in a nutshell. To understand this completely, we have to go back in time a bit and look at the history of how these capsules were developed theoretically, or how these ideas were developed theoretically. Okay, so let's go back in history. So let's look at mid 1850s first. So this was one of the very first times when a pneumatic railway system was built in several countries, in places like Dublin, London, and Paris, and they were meant to transport parcels first. But since back in the day the technology was not really efficient, so the size of the containers were actually large enough to carry people too. Now let's go back in time. So let's move on to 19th century. There were several versions of the pneumatic tubes from mid 1850s to 19th century. But let's look at one of the major commercial uses for which they were built for. So by the end of 19th century, once people were able to master building pneumatic tubes, they built large scale pneumatic tubes for commercial applications, that is for transporting mail and other messages. Now, I've used the word pneumatic tube a lot of times by now, so let me just step back and explain what a pneumatic tube is. So, pneumatic tube would be a container which is very closer to vacuum, which uses compressed air for moving solid packages from place to place. So it differs from a regular tube in the sense that usually when we say something called a tube, it is used to transport liquids. The pneumatic tubes instead were used to transport solid packages like a mail and etc. And this is 19th century, and one of the very first models of using a tunnel or a tube for large scale transportation was theoretically proposed by a NASA pioneer called Robert Goddard. So his idea was to create vacuum tubes. So he theoretically wrote a paper on this idea in 1910 and estimated that if we are able to build a vacuum tube from Boston to New York, and the yeah. So if we are able to build such a tunnel from New York to Boston, so we would have been able to transport people in about 12 minutes, according to his theory. Now moving on to early 2000s, so the next major application or a proposal was proposed by ET3, a commercial company, so which designed a small scale pneumatic and a maglev train, which is also built on similar principles, which we discussed earlier on pneumatic tubes. So as you can see in the picture, the design features car-sized pods that would travel in elevated tubes. So it would not be on the ground; it would be at a much higher level and elevated level than the ground. Okay, now moving on to the present. By that I mean let's early 2013, 2012, 2013, when Elon Musk wrote his first white paper on hyperloops. So essentially, now we understood the history of how humans have been able to evolve this technology, that is, be it using compressed air for transporting mails, and then trying to prove that we could use vacuum tubes would be a better alternative for transporting people from place to place. So Elon Musk suggested this idea that so he was actually inspired by all these ideas, and so using low pressure tubes to attain a very airline speeds, that is high airline speeds, so theoretically close to 500 miles per hour. That is because since we are using low pressure containers, there would be very little aerodynamic drag, which will allow us to attain such high speeds. So to uh, to use an analogy in terms of the road transport, a very less aerodynamic drag would be like very less amount of friction. So essentially, we would be going from Flintstones to Jetsons because we'll be attaining such high. We have been evolving in terms of transportation industry. We'll be moving on from this to this. Okay, now let's look at the motivation behind developing this project. So in about 2012, 2013, the Californian government accepted a proposal for high-speed rail system between Los Angeles to San Francisco with about 68.4 billion budget. Now, after this was accepted, Elon Musk argued that with a travel time of about 2 hours 38 minutes by high-speed rail, although it appears faster than the road transport, which is about 5 hours 30 minutes, the cost was still comparable to that of traveling by air. That is like you're paying around $105 as compared to 150 by plane. So he argued that with about similar or a much lesser cost, we could develop a much more high speed transportation system using low pressure air containers, which reduces the aerodynamic drag, and also which won't be a hindrance to the existing highway system because you could build this hyperloop on a much elevated level. So he established the following objectives for hyperloop. These couple of points, that is the lower cost, it has to be faster, it should be safer, more convenient, immune to weather, especially earthquakes, and lesser carbon footprint, and no disruptions along the route. That is explained by the fact that you won't disrupt. So to build a rail, you have to you're going to disrupt the ecosystem, and you're going to disturb the land in which you'll rail the railroad. You'll develop the railway system. Whereas for Hyperloop, you're just going to use pylon tubes and build these pylon levels, and you build these tubes on top of them, and they're at a much higher elevated level, so it doesn't disrupt anything. And also sustainability. So Elon Musk also suggested that in his first proposal, it is suggested that since there are solar panels built on top of these tubes, the whole Hyperloop can be self-sustainable. So this is one of the schematics between San Francisco to Los Angeles. The first one's developed, and let's look at one of his one more argument of his was that if you look at the energy consumed per passenger. So this graph explains it for the existing modes of transport, that is car, aeroplane, the Tesla Model S, Hyperloop, train, and motorcycle. Of course, Hyperloop is still theoretical and it's a proposed mode of transport. So if you look at it, the least amount of energy is occupied by the Hyperloop. So this also proves that this is a much better mode of transportation to use in terms of the energy consumed and also lesser carbon footprint. And this is the top level schematic of the Hyperloop. That is, if you look at the design parameters, so we need the pod, the tube, the mission, and the ticket cost. So, okay, now let's look at the working principle of Hyperloop. So the idea and the basic working principle. So we can break down the Hyperloop system into 7 major components, as you can see here. The tube, the vehicle or the pod, the propulsion system, the suspension system, energy management, timing, and the route. Now, so to sum it up, so I'm going to explain these things in detail later. So to sum it up, these pods are transported. So the tube is mounted on the pylon levels, and the tube is built on the pylon levels, which also has solar panels on top of it. So these capsules are transported in this low pressure tube at a very high speeds, and also to reduce the speed, also at a lower speed. Now, these capsules are also supported by a cushion of air and pressurized air, basically, which also has very less aerodynamic drag. So, how does it accelerate? So, a magnetic linear accelerator is fixed at various stations, and these pods, or the passenger pods, have rotors inside them which assist in this mechanism. So let's look at these individual components, a top-down engineering analysis of Hyperloop. First, the capsule. So the first proposed idea, or the first design level idea of the capsule, was it could carry about 28 passengers and along the interior of the tube, and a Hyperloop pod would depart every 2 minutes from Los Angeles to San Francisco. So each capsule or the pod would be separated by about 23 miles on an average during the operation. And as mentioned here, the capsules are supported via air bearings. Next, second most important thing, that's the tube. So this tube is made of steel, these tubes, and each tubes, so in the first track between LA and SF, there are two tubes which run side by side and parallel to each other. And the pylons are placed every 100 feet, as shown in the picture here, to support the tube. And the whole system can be self-sustainable because of the solar panels attached on the tubes, so using the solar energy. Propulsion system. I already explained how the acceleration works, that using the rotors inside the pod and the linear accelerators at each station along the length of the tube, which assist in the acceleration of the capsule. And next, the route. So for a Hyperloop to be successful, and since we are traveling at the speeds of around 500 miles per hour, the route has to be as long as possible. There should not be any wide turns. It should be as straight as possible. So if you see the picture, the first route that was proposed, or that was to be laid between Los Angeles to San Francisco, the most of the sections in this are pretty straight. Okay. All right. Now we learned about Elon Musk's vision and the SpaceX, the initial designs on Hyperloop. So I would also like to speak about two more companies, that is Hyperloop Transport Technologies and Hyperloop One, which also picked up this idea and after the first white paper and started developing initial versions of the Hyperloop. And last year, Hyperloop One was able to successfully test the first version of Hyperloop in about a 500 meter track, and they were able to attain speeds of about 250 miles per hour, which is not still the quickest or as proposed in the paper yet, but it is actually a really good start, and it is sustainable till 500 meters. So it can be built further. Now, Hyperloop One announced their vision for North America in their conference last year. And so they talk about, since they're able to successfully complete the phase one, they're talking about the plans of the next phase, that is building by 2030, building these Hyperloop tracks all over North America. And this is a really exciting phase ahead, because if you look at it from Boston to Somerset, the trip it's going to only cost 5.3 minutes. And similarly, you can look at Denver to Dallas, 73 minutes. And Chicago to Columbus, it's about 29 minutes. And Fort Collins to Denver in about 7 minutes. Dallas to Austin in about 20 minutes. Los Angeles to San Diego in 12.5 minutes. Seattle to Portland in 17.2 minutes. So if Hyperloop One or Hyperloop Transport Technologies or SpaceX for that matter, any one of these companies is able to pull it off, and if they're able to make this fifth mode of transport a commercially viable application for the passengers, if it suits the demographics, if it works with the economies to scale, it is a really exciting time ahead. So I end my presentation here to conclude. So what we did today was basically understanding the basic principles of Hyperloop and how was it throughout the history of humanity, how have we been able to evolve the ideas of transportation. And this time is really exciting because we are able to achieve about 250 to 300 miles per hour in testing right now for about 500 meters track length. And SpaceX is actively launching competitions, the Hyperloop contest every year annually, in which a lot of students from these prestigious universities take part. So it's really exciting times ahead if you're able to build one of the at least a commercial viable application for humans. Thank you.